Today our topic is line of best fit. So our essential question is, how can I find and write an equation for the line of best fit? First off, some vocabulary. A scatter plot is a graph used to determine whether there's a relationship between paired data. So it's kind of in the name scatter plot, so the points are kind of just scattered on the graph. Sometimes they'll be a little bit closer together, sometimes they'll be further apart. The line of best fit is where we're going to focus today, and it's a line that models the trend in the data. So if you look here, it's this line in blue. So it finds like that trend, that pattern, and it kind of just cuts right through the middle of all the points. So it kind of wants to be right through the middle of the group of points. So we're going to do an example together, and then you guys are going to try a practice problem by yourself. Below are the measurements of a baby alligator by month. So 0 month would be like when it's born, and it's 22 inches in length. And then after the first month, it's 22.5 inches. After the second month, it's 23.5 inches, and it continues. So here we have the measurements for up to month 7. First off, we want to graph the data in the table. Well, now, if you notice, we don't have any numbers on our graph. We just have a graph. So first off, let's label our x-axis and our y-axis. Now, we want to get to 22, but we don't want to count starting at 0. We want to use just like really focus on the numbers 22 through 29.5. That's the range of our data. So we're going to draw this little, it's kind of like a squiggly line almost. And it just means that you're going to skip a few numbers. So you're not going to start at 0. So you just draw that little squiggle right there at the bottom on your y-axis, and that just means you're going to skip a couple numbers, and that's okay. You're allowed to do that. You're allowed to skip. So then if we start at 20 or 22, we can start at whatever, and we can count by 2. So if we wanted to just start at 22, and then we could just go up every other one. So don't like leave a space in between. So here's 22, and then skip a line and then go to 23. And we can go 25, 26, 27, 28, 29, 30. We could say 31. We're not going to need that many measures. And then on our x-axis here, we can just go 0, 1, 2, 3, but we can also skip a line in between there just to kind of give us a nice spacing to our graph. You don't have to skip a line, but sometimes it can be nice. And since we have the space too, let's skip a line. Now we want to plot those points on our graph. You guys should be able to do that. We practice that in the do now. 0, 22 would be right there. 1, 22.5 would be halfway between 22 and 23. 2, 23.5. 23.5 would be halfway between 23 and 24. So here now we understand why we were skipping a line in between to make room for those 0.5s. So go ahead and plot those points on your graph. When you get done, your graph should look like this. Now you should notice that the points are pretty much forming a linear function. They're not quite in a straight line, but if we were to make a straight line through this data, it would kind of go right there. So not quite through all the points, but you see we have these 2 points are below the line, these 3 points are above the line, and it does go through 3 of the points. So it kind of just, that would be our line of best fit. So that's that line of best fit that we just drew. Then we want to write an equation for that line of best fit. That line of best fit is going to allow us to predict, to figure out how long would the alligator be given just any month. So if we wanted to know how long he's going to be after 22 months, instead of having to extend this chart and make an accurate guess, we use that line of best fit because it shows the trend in the data. So identify 2 coordinate points. Well, let's use that y-intercept because that y-intercept is helpful. So 0, 22. And then one of the other 2 points that goes through would be this point, so 3, 25. And if you don't remember what coordinates they are up here in the table. So just find the correct x value, and then it gives you that y value that goes with it. Now we're reviewing what we did before we went on winter break. Find the slope. Use that slope formula. x1, y1, x2, y2. You guys are going to get sick of slope, but we're going to really hammer it in this semester. So 25 minus 22, y2 minus y1, over x2 minus x1. 25 minus 22 is 3. 3 minus 0 is 3. 3 divided by 3 is 1. So our slope is 1. So down here where it says write the equation, in our slope blank, we can put 1 because we know our m is going to be 1. Identify the y-intercept. The y-intercept is where we cross the y-axis. Where do we cross the y-axis? Find your y-axis. Where do we go through that y-axis? Right here at 22. So our y-intercept is 22. So that would go where b is. So y equals 1x plus 22. That would be the equation for our line of best fit. And that is going to allow us to answer this question here at the bottom, which says make a prediction. What would be the length of the baby alligator on the 12th month of measuring? Now, months was your x. Your x was months. So that means if we know that x is equal to 12, we want to solve for y. What is y going to be when x is 12? Which is where our equation comes into play. Our equation is y equals 1x plus 22. Well, we know x is equal to 12, so we can make that substitution. We can say y equals 1 times 12 plus 22 and solve for y. Y is equal to 1 times 12, which is 12, plus 22, which gives us 34. So y would be 34, which would mean the alligator would be 34 inches after 12 months. So after a year, the baby alligator would be 34 inches long, so almost a yard. Not quite a yardstick. Alright, that's all the notes I have for you. Thank you for watching this video, and please subscribe to my YouTube channel.